Topic 1.2 Physical Quantities and Units. Physical quantities. In study of physics, it is necessary to measure a range of quantities from such obvious ones as distance and time to more subtle ones like magnetic flux density and capacitance. All these things that measured are called physical quantities. When studying part of an atom, it might be necessary to know the quantities, mass, and diameter. When studying a star, the quantities, temperature, and age may be important. In an electrical circuit, current, voltage, and resistance are the relevant quantities. Derived and base quantities. Many physical quantities are combinations of others. For example, a volume is the product of three lengths, while speed is a length divided by a time. These are derived quantities. It is obvious that it is necessary to define some quantities to start deriving other quantities. These defined starting quantities are called base quantities. There are 7 internationally accepted base quantities. Number 1, mass. Number 2, length. Number 3, time. Number 4, electric current. Number 5, thermodynamic temperature. Number 6, amount of substance. Number 7, luminous intensity. Units. In order to meaningfully express the value of a quantity, a unit is necessary. To avoid confusions, an internationally accepted system of units named as System International D Units or SI units is used worldwide. This system defines 7 base units for 7 base quantities, and units of other quantities are derived using these base units. Some derived units have special names for them, for example, Newton and Joule. Base unit in SI units for each base quantity. Base SI unit of mass is kilogram. Base SI unit of length is meter. Base SI unit of time is second. Base SI unit of electric current is ampere. Base SI unit of thermodynamic temperature is Kelvin. Base SI unit of amount of substance is mole. Base SI unit of luminous intensity is candela. Definitions of base units. These definitions have been changed from 20th May 2019. Kilogram. Old definition. The mass equal to that of the standard kilogram prototype kept at Sèvres, France. New definition. The kilogram is defined by setting the Planck constant h exactly to 6.62607015 into 10 to the power minus 34 joule second, given the definitions of the meter and the second. Meter, all definition. The equivalent length of 1,650,763.73 times of wavelength of the electromagnetic wave, which is emitted by transferring electrons between energy levels 2p10 and 5d5 of krypton 86 isotope. New definition. The distance traveled by light in vacuum in 1/299,792,458 seconds. Second, all definition. Time taken for $9,192,631,770 oscillations of the wave emitted by transferring electrons between two microlevels of energy of the cesium-133 isotope at its ground state. New definition. The duration of 9,192,631,770 periods of the radiation corresponding to the transition between the two hyperfine levels of the ground state of the cesium-133 isotope. Ampere, all definition. The constant current which, when it is flowing in two infinitely long parallel thin wires that are 1 meter apart in vacuum, produces between them a force per unit length of 2.3 into 10 to the power minus 7 newtons per meter. New definition. The flow of exactly 1/1.602176634 into 10 to the power minus 19 times the elementary charge E per second, equaling approximately 6.24150907444 into 10 to the power 18 elementary charges per second. Kelvin, all definition. 1/273.16 of the thermodynamic temperature of the triple point of water. New definition. The Kelvin is defined by setting the fixed numerical value of the Boltzmann constant K to 1.380649 into 10 to the power minus 23 joules per Kelvin. Given the definition of the kilogram, the meter, and the second. Mole, all definition. The amount of substance that contains as many elementary units as there are atoms in 12 gram of carbon 12 isotope. New definition. The amount of substance of exactly 6.02214,076 into 10 to the power 23 elementary entities. This number is the fixed numerical value of the Avogadro constant Na when expressed in the unit per mole. Candela. All definition. The luminous intensity produced normal to the surface area of 1 upon 600,000 square meter of a black body at the temperature of platinum, solidifying under the pressure of 101,325 Pascal or 1 atmosphere. New definition. The luminous intensity in a given direction of a source that emits monochromatic radiation of frequency 5.4 into 10 to the power 14 hertz, and that has a radiant intensity in that direction of 1 upon 683 watts per steradian. Supplementary quantities and their units. Number 1, plane angle, its unit range. Number 2, solid angle, its units steradian. Definitions of supplementary units. Number 1, radian. 1 radian is the angle subtended at the center of a circle by an arc that is equal in length to the radius of the circle. Number 2, steradian. A steradian is the solid angle subtended at the center of a unit sphere by a unit area on its surface. Few derived units having special names. Force, its unit Newton. Pressure, its unit Pascal. Energy, its unit Joule. Power, its unit Watt. Electric charge, its unit Coulomb. Potential difference, its unit Volt. Resistance, its unit Ohm. Capacitance, its unit Farad. Frequency, its unit Hertz. Prefixes in SI units. 10 times deca. 100 times or 10 to the power 2 times hecto. 1000 times or 10 to the power 3 times kilo. Million times or 10 to the power 6 times mega. Billion times or 10 to the power 9 times giga. 10 to the power 12 times tera. 10 to the power 15 times peta. 10 to the power 18 times exa. 1/10 or 10 to the power -1 deci. 100 or 10 to the power -2 centi. 1000 or 10 to the power -3 milli. 1 million or 10 to the power -6 micro. 1 billion or 10 to the power -9 nano. 10 to the power -12 pico. 10 to the power minus 15 femto, 10 to the power minus 18 atto.